little bit about your work? I find it fascinating, the sifting through history in a ice core.
Yeah. Well, I should say that, when I came to Ohio State, I came here to study coal geology because I grew up in West Virginia.
Oh, my.
And I came here looking for doing something, learning something to get a job. And then my first quarter here, I was offered a position in what was then the Institute of Polar Studies to look at ice cores. And as a young student, I thought, oh, this is crazy. I mean, first of all, glaciers only cover 10% of the surface of the planet, and they aren't where people live.
Yeah.
So, who's going to pay you to look at glaciers? I mean, it just didn't make sense. But it took about a year and a half to start thinking about the possibilities of what you could do with ice. And, timing is so important. It was all the pioneers in my field were alive. I got to meet them.
Oh, golly.
And so it was a very exciting time.
Yeah.
And but there was no way at that young age I could see where this would ultimately lead. But what's in the ice is, we have a history of temperature and the isotopes of oxygen and hydrogen that make up the water molecules.
Yep.
We have a history of precipitation. You've got these annual layers.
You can tell an annual layer, like rings of a tree.
Just like a ring of a tree. And if you go to a place like in the tropics where there's a wet and dry season, every dry season there's a dust layer.
Wow. Even at 20,000
at 20,000 feet, and you drill through that, and you can actually date the core when it's coming out of the drill because you can see these layers.
Gosh.
And then you measure the thickness of those layers, and you can get the precipitation of the past. There are very few archives that allow you to do that. But we also measure the chemistry, soluble chemistry, anions, cations. We look at all the radioactivity, all the thermonuclear bomb tests that humans have done.
Yeah.
Have left radioactive layers in all the glaciers of the world. Well, for us, we know when the bombs went off.
Yes,
and so they become timelines. So we can go to central Tibet, where we have no history, and we can locate that layer, and we know what the accumulation has been since that layer was deposited. So anything that's in the atmosphere gets archived.
Are there like pockets of air in there?
Oh, there are these little bubbles of air, and it's our only record of the atmospheric composition of the past.
Have you ever wanted to just take a breath of it and see?
Well, it's amazing that we now have histories from Antarctica that go back 800,000 years, where we can look at carbon dioxide and methane and nitrous oxides. And this is probably, of the ice core work, maybe one of the most important things that have been found, is that if you look at 800,000 years of history, what you see are the orbital forcings. You see CO2 going from 180 to 200 parts per million during the time that Columbus, Ohio was under an ice sheet, to 280 or 300 parts per million during the warm periods when the ice melted back. And we can see these cycles, these 100,000 year cycles. Then you come up to our time. Our time, 2 years ago, we passed 400 parts per million.
Because you just said 200 to 300 times in the warm periods, and now we're 25%.
We're 100 parts per million by volume higher than anything in the last million years.
Oh my gosh.
And that's where you get the perspective of our impact on the system.
Yep.
And so when you make changes like that, you expect to see changes in the system, and we are.
Yep.
And the real concern is if you look at the projections, if we don't change the course we're on, by the time we get out another 90 years, we're going to be looking at CO2 levels that are 800, 900 parts per million. Nothing like that.
Yeah.
And the system will change with that.
I remember them saying that their hope was, best scenario, that we would make it only up to 500 if we are able to curtail many of the activities, and that's still scary.
It's a very complex, it's a huge problem because we all contribute in our daily process. And of course, we've never had in the history of the Earth, and this really was what makes it different, 7.3 billion people.
Yes, yes. Some students will ask me, well, aren't they all in their respiration putting out CO2? Does that impact it? I don't think it does, but would you answer that question?
Well, I think if you look at the natural processes of emissions on the planet and the sequestering in the oceans, left to its own devices, that natural system would keep
Become a steady state.
and we've had, and it's one of the amazing things about the Earth's history is that it has always been able to balance the needs for life by weathering processes or the lack of weathering. It gets colder, you have less weathering, so less CO2 is brought out. CO2 rises, temperatures rise. If you get too warm, you get more weathering. Takes the CO2 out, and so there's a balance there. But this balance occurs on thousands, millions of years.
Yes.
And so we come along, and then suddenly we can bring all this stuff to the surface, and the system can't sequester it fast enough. And then one of the other issues that we, as climate scientists, are concerned with is the fact that once you emit things like CO2, if you look at the projections, if we found an alternative energy tomorrow, and we say, let's look out how much of the CO2 we have in the atmosphere today would be there in 100 years. And the fact is 1/3 of it would still be there. If you look out 1,000 years, we'd still have 20% of it.
Yeah.
So once it's released, it has a long lifespan.
It's a very stable molecule.
And it takes the system a long time to pull it back out.
Yep.
And then on top of that, there's a lag in our climate system. We will really not see the impacts of our 400 parts per million by volume of CO2 that we have right now for another 20 to 30 years, because it takes a long time to warm up oceans and to warm up ice sheets and to melt ice sheets.
Yes.
So a lot of energy is now going into those natural archives of energy.
Yep.
So the system, even if we change, we are looking at significant change over the next 20 to 30 years from what we've already done.
Yes. And it's hard to sell that to policymakers, I think. But
well, this is the beauty of glaciers. Glaciers have no political agenda. And so we can look at them. We have photographs taken, in the 1930s and the 1900s, and we have them from all over the world. And when you look at where they were, and you look at where they are now, and you look at the rate at which they're retreating, very hard to argue with.
is it increasing?
It's amazing how rapidly, and every place where we have, again, you have to look at the balance of evidence.
Yep.
So, I mean, if you go around the world, if you look at the Brooks Range in Alaska, 100% of the glaciers there are retreating in today's world. Mm-hmm. If you go southeast Alaska, 98% are retreating.
Okay.
You go to the Himalayas, where we have over 46,000 glaciers and very few observations, but of over 7,000 have been observed, 95% are retreating. If you go to the Alps, 99% are retreating in today's world.
Boy.
If you go to the tropics, where we've spent a lot of time, and we consider it a very important part of the world because 50% of the surface of the planet is there. I mean, we forget we live on a globe. And so 50% is in the tropics and 11% is in the polar regions. So 100% of the glaciers in the tropics are retreating in today's world. And if you go to a country like Peru, 70% of the tropical glaciers on Earth are in Peru. So they are immediately affected by the loss of that ice. And they're seeing that now in their ability to produce hydroelectric power.
Yep.
76% of their electric comes from hydro. And that's suddenly at risk, particularly in the dry season, when the rivers flow becomes
They're
very
seeing
low.
that in California.
Well, this is the other part of this whole system, and why I think it's going to be so important for young people is that we're seeing more extreme events.
Yeah.
We see superstorms like Superstorm Sandy, super typhoons. We just had a Category 5 out in the Pacific Ocean, and it destroyed 90% of the buildings in the capital city. Nature is extremely powerful. And then we have in our own country, we have California, and it's now a 500-year drought that we're in.
Yes.
And
With no end in sight. I mean,
the snowfall as of the end of February is only 18% of normal in the Sierra Nevada. And just, I think it was today or yesterday, the governor came out with these water restrictions. And the projections are they have 1 year of water supply.
well, up in the Olympics, you know, they have something like 3% of the ice pack that they usually do. And then they got a foot of rain because it was too late in the season.
Yes.
Instead of snow. And that's a difference of 2 weeks to 3 weeks difference in time, you know.
Well, this is the other thing that happens as temperatures rise. The zero isotherm, where the level between where you get rain and snow, also rises.
Yeah.
And we're studying a glacier right now over in New Guinea, in the middle of a tropical rainforest. And in the last 10 years, it's gone from snowfall to rainfall. And if you want to destroy a glacier, you rain on it. Because you put so much energy into the surface. And when we were drilling there in 2010, we had a tent that sat in one place for 2 weeks. In 2 weeks, the whole surface lowered 30 centimeters.
Oh my gosh.
And if you calculate that for a year, that would be 7 meters a year from the surface down.
So about 20 feet.
And yes, and the glacier is only 32 meters thick. So you do the calculations, 2017, 2018, 2018,
Yep.
they'll be gone.
Yep.
And
Glacier National Park will have to be renamed.
Absolutely correct. I mean, when that park was formed, there were 155 glaciers.
Yeah.
Last count, there was 23.
Yes, yes.
And they're disappearing very rapidly.
Well, I think that on a positive note, I think that the evidence is becoming clearer and clearer. I know the IPCC just put out their 5th report last year, and there was controversy after the 4th. The 4th was when they said unequivocally it's the impact on humans that's warming up. And I think the UN said, this one you have to be sure that there's no chance for discussion of impropriety. And I think that has been the case. And in fact, it came out with such a quiet.
Anytime you can get scientists 95% confident that humans are driving the change, that's almost unheard of in
and
science.
98% of them saying this.
Yes. And the other part of this is that the fact is that we have over 3,000 scientists worldwide that are looking at climate change issues. If any one of them could find a credible other process that would account for what we're seeing, they would win the Nobel Prize.
Oh my goodness, you're absolutely right.
And you wouldn't believe the amount of money that companies are been paying to find other sources, and we haven't done so.
Yeah.
And so to me, this is probably the most compelling evidence that we've pretty much got this sealed.
Yes. And I think it's a matter of time. It's a race. But I think it's going to.
And for our work, it's a race because those archives are disappearing.
Oh my goodness, sure.
And we didn't know this in the 70s when we started. But probably one of the greatest things we've done is to recover the archives, produce the data sets, and we have now over 7,000 meters of core archived, because we consume about half of it in our processing. Okay. We put some away. We store it at minus 35 degrees Fahrenheit, with the idea that 20 years from now, there will be new techniques, a better understanding, but you will not be able to go to Kilimanjaro or to New Guinea and actually get that archive.
That breaks my heart.
Or, to me, it will be sad for the next generation to see snowfields on the glaciers on Kilimanjaro that were made famous by Ernest Hemingway, only in textbooks.
Yeah.
Photographs will be only in textbooks, and that's part of our history, and I think from our perspective as human beings, you know, the societies, our civilization as we've known it, have developed in only the last 10,000 years. And as I say, with 7.3 billion people, and when you look at that number, you know, that's a big number. But what you don't see is what we need. You know, we need about 30 billion chickens and ducks.
Yes.
We need huge amounts of cattle and sheep and pigs. We have over 400 million dogs, 500 million cats. I mean, this is what humans do.
Yeah.
And of course, we need food, and we also need croplands to grow. So we cut the natural forest, and when we do that, we change the albedo of the
Yes.
earth.
Yep.
And all that feeds back as a human impact on this planet.
And I think the State Department has a large area that looks at unrest due to climate change and droughts.
This is a growing problem, and we interact with the Naval War College. Of all of our military groups, the Navy is most at risk, and the Navy, you know, you talk to them, they deal with what is, and they know that there's much more open ocean up in the Arctic than there used to be, and that water has to be patrolled, and you get in all kind of geopolitical issues of what belongs to who.
Well, the Russians have been putting radioactive materials down there.
There are all kind of issues that come out of the woodwork when these things happen. But when you think about the Navy, all their strategic bases in the Pacific are at sea level. All their infrastructure is at sea level. Where they build their ships are at sea level. And so those all become at risk with rising sea levels, increasing storms. And what they say is they deal with what is. And I think at the end of the day, when it comes to climate change, we can debate and we can argue, but it will come down to physics and chemistry. And what is what we deal with.
Yes.
And that will unfortunately become very clear for all of us.
Well, on that note, I think that I say thank you so much.
Well, thank you, Barbara.